So this is another example of using XyGrib, and this time we want to take a look at it for a regional high-resolution model. And if we take a look, and I'm going to do an example in Puget Sound. This, in fact, is where I'm sitting right now, right about right there on this place right here. And so we want to look at some sailing in here. See, before we've been looking at ocean models, ocean winds out here for doing coastal passages or ocean crossings. But now we have to do a whole different type of model. We can't use this GFS and these other wonderful models for this ocean sailing. Those are global models. Those aren't going to do us any good in here. For one thing, the data points would just bounce right across here. There'd be maybe one data point right across here. We need to get several data points across this land here. If we go in here, that's not it. If I just go in and choose a region here, and then go here, then they have, for the U.S., they have NAM CONUS. Now, in principle, NAM CONUS ought to be 3 kilometers, but this is actually 12 kilometers. So we can't use this NAM CONUS. There's a lot. These are over here plenty good enough for doing things in Europe. So they have very fine high-resolution wind forecasts for Europe, and you can practice there. But if we want to practice high-resolution forecasting in the U.S. using publicly available, easy-to-access GRIB files. In other words, I don't want to sign up for a program that costs money and I have to pay for the data. I want right now to get things that are publicly available, and that would be, we want to use the HRRR model, high resolution rapid refresh, and we can get that data from SailDocs. And there's a link in the I have some background discussion in the link online about this. So here's the mail that I just sent to SailDocs. Send HRR, and then this is the latitude longitude box that we're looking for. Notice that you want to be careful to use decimal points because we're talking about very high resolution here. 0.03 degrees, 3 kilometers. And so this model will go out 18 hours. And there's further discussion of that, but we're going to take 18 hours of it, and we're going to take parameters wind, pressure, and what's called the composite reflectivity. That's a simulation of the weather radar. That's the best way to look for squalls and instability. So those are the 3 parameters we're going to get. We send them that, and then the mail comes back. We did this before. And then we open that and then come down here, and then I just say download, and then I dropped it right into here. So that's that file saved here. Cancel, we're done. So that's the way you get it. That whole process takes about a couple minutes. Now, if you're offshore, then you would have to send this in through your Iridium Go, but that's another topic. There's a lot of sophisticated equipment. LuckGrib and various other companies have direct satellite connections for that. But for now, we just do that. Okay, so we've got the data stored, and then we go in here to the file and open, and that's the folder we just looked at, and that's there, and we open it. And there's the data right there. And it will always default to filling up, to showing the size that you ordered. I could have been set something totally different. And so here's the data, and now you see that we have, now that's still scaled there, or interpolated. Remember what you can do. You go up here, do I remember? Weather map, weather options, wind on grid, GRIB grid. Okay, now that puts a real data point. So there you're seeing the real resolution. So in this area going across, this is about 12 miles across here, and you see how many data points you have. With the GFS, you might have like 1 or 2 at the most, 2 points. Okay, so you see, and then that's that. But this is, again, that's just a check to see that you're looking at what the real resolution is. It's a truth meter. It's always worth checking that out. Okay, where am I? Weather option. But I'm going to shut it off because this program does do a nice job, an intelligent job of scaling and showing you the wind vectors at the right density and so forth. So here they are, and that's the data. And so then you can step through it like this. Right, and then we're looking at, you see, you can actually make sailing plans, and a little bit later we're going to actually do some optimum weather routing, and we can actually do optimum weather routing. We can put our boat down here, we can put in our polar diagram, and we can actually figure with how this forecast is going how to best sail to get up to here. At least you get the first shot, you plan at it, and then this model is updated every hour. So when you would get this, you would plan it out, then you would just go in and download every few hours. You just download this model again to see if it's changed, and you have 18 hours of forecasting. So if you're on like a day sail or a race in this area, you can keep right on top of what the best forecast is this way. And you see there's a lot going on here with the wind, tremendous amounts of wind information. Let's see, what else did I want to show here? Oh, you want to be sure, map quality, you want to be sure you're showing this background map because remember, this is not a charting program, so you're not going to load high resolution maps or nautical charts in here. We're going to deal with this, and when you install the program, you want to be sure you take high resolution. If you don't have the high resolution, then you either download the program again and install it, or you shut the program off, or you run this thing and then you shut the program off, and it'll give you the option. Look at that, update all components, update add and remove components, next. See that? Look at that. You see you have the option to add the high resolution right there. No, I don't want. Wait a minute. What's my question? Back. Close. Do you want to quit? Yes. Okay. All right. So that's it. Now the other thing. Let's take just a real quick look at go into the weather map and turn on the reflectivity. That's the radar simulator. And so where are we here? I'm way up here. Here's the yellow part is now. That's now. Here's when the model was run. It looks like it was run an hour ago. And then I can step through this. Here's an hour. And I have to okay, and now nothing's still going on here. White, there's nothing there. Nothing here. Well, here we're getting a little bit. Nope, that's still really no. Oh, well, here's how you test it. You just put the cursor over and read it, and you read it right down in here. And then I refer you to our textbook. Our textbook we take this scale, which is a fairly standard color bar for this functionality, because remember, it is forecasting simulated weather radar. And if you look at weather radar very often on your computer or whatever, then you will see that the color bar is pretty standard for it. And what we show in the book is that you're getting sort of, you don't really get serious squalls till you get up here at 40, 45 on this value in the units of this thing, dBz. It's a decibel logarithmic scale, but you start getting into really heavy rain and instability as soon as you in this value here. Here's where the real squalls begin. And then we discuss, when you see this pattern coming through here, you'll see when this starts getting yellow here, you'll see really sharp edges. I'll make another video later to concentrate on this. We'll go down to Florida or somewhere where they got a lot of squalls, and we can look at that. But anyway, you can go step through here and see that there's going to be some unstable, squally weather here in the second half of today. But we should know that. I can also look out the window and tell you that I'm sitting here in this area, and it's been rain squally, although not this moment, but it looks like tomorrow night it will be. All right, that's the idea. Now we can go back to weather map. This is shutting off that grid, and we just look at the wind. So just look at that beautiful detailed wind forecast here. And you can practice with this on your own area wherever you are in the U.S., or you can go to, if you're in Europe, you can do some very detailed, beautiful data there. I'm stopping there.